Hello everyone. So in the last lecture we learned how to write the defect reactions. So more specifically we have learned that CaF2 doped in CaO, and ultimately we balanced oxygen going to interstitial and vacancy of cations, where the cation was calcium, and that we balanced involving electron. So electron are involved to balance the overall reaction. So that's why the defect reaction was called oxidation defect reaction. Today we learn how to the defect reaction, but reduction defect reaction, and let's take an example. Let's take an example. So this was our last class. Let's say we have thorium oxide THO2, and we would like to dope CaO, calcium oxide. First I would like to say this has the fluoride type crystal structure. Fluoride type crystal structure, and this, as I already said in the last class, NaCl type crystal structure. NaCl type crystal structure. Now the same things. First do by cation balance. By cation balance, here the number of cation is 1, and here is also number of cation is 1. THO2, here is CaO. So by the assumption of Kroger-Vink notation, cation will goes to cation side and anion will goes to anion side. So here calcium is going to thorium side. The charge of thorium is plus 4, and charge of calcium is plus 2. So this minus, it will be minus 2. So the overall charge of this defect species is minus 2, and one oxygen is going to one oxygen site of THO2, that gives neutral structure, and one oxygen is remaining here, so that will create oxygen vacancy. So two negative charge and two positive charge, so the overall reaction is balanced from charge neutrality point of view. Now by cation balance, by anion balance, THO2, we are doping CaO in THO2. here the number of anion is 2, here is 1, so we have to balance it by 2. Similarly, cation will goes to cation side, anion will goes to anion side, and the reaction will be in this, will be CaO going to thorium, giving 2 negative charge, plus 2 oxygen going to oxygen side, giving 2 negative charge, and 1 calcium is remaining here, so that will goes to interstitial site. Interstitial site of TiO2 crystal structure. So this calcium is going to sit in the interstitial site of TiO2 crystal structure, and what will be the overall effective charge? This will be 2. How I am writing this? The charge of calcium is plus 2, and if we assume that interstitial position has no charge, let's say 0, so overall charge will be plus 2. So here also, from charge neutrality point of view, the reaction is balanced. Now, what is thorium the structure of thorium oxide? Let's say we are drawing thorium oxide, okay, TiO2. Here cation is thorium, so the cation are sitting at corner, and face centered as well. So if we write a line here, so it will look like in this way. There will be a connection. And here, right? So 8 atoms in the corner and 6 are in the face center. These are the thorium, TH4 plus. And the oxygen will sit at this position. So if we write the coordinates, how it look like? Thorium 4 plus, the coordinates is zero zero zero, half of 0, 0, half half, and half 0 half. And what will be the coordinate of oxygen? If we write that coordinate of oxygen anion, that will make a sense and it will be clear to you to visible where the anion are sitting. 1 4 1 4 1 4, 3,4 position, 3,4 position and 1,4 position. Now 3,4, 1,4, 3,4 and 1,4, 3,4 and 3,4 also, and the other coordinates are 3,4, 3,4, 3,4 and 1,4, 1,4, 3,4. So 1,4, 3,4, 1,4 and 3,4, 1,4, 1,4. So this is the crystal structure of CaO2, fluoresce type crystal structure, and in TiO2 in TiO2 anion Frankel defect are prominent. Anion Frankel defect is prominent. So if the anion Frankel is prominent in TiO2 structure, that means vacancy of oxygen and oxygen going to interstitial position will be present in that crystal structure. So after the doping of CaO in TiO2, we are seeing that here vacancy of oxygen is creating, right? So depending on the crystal structure of TiO2 at this up to this level, we can say that this defect reaction is predominantly occur in this material. Now we would like to balance this vacancy of oxygen and calcium interstitial in terms of electron or hole. So how we can write that? First we will balance the vacancy of oxygen. Vacancy of oxygen. So how we can write it or balance it? Oxygen here, so we have to balance by oxygen plus, here is 2 positive charge, so the 2 hole here will be here, right? So you can think in this way, the lattice oxygen is leaving out from the crystal and creating an atomic oxygen and as well as leaving oxygen vacancy in the crystal structure. Okay, so what would be the overall reaction if we put the this expression into this expression? The reaction will look like in this way: CaO plus half of O2 TiO2, so CaTH plus 2 oxygen plus 2 hole, right? Now, right now we would like to balance this calcium interstitial also. How we can balance calcium interstitial? Here is calcium interstitial. So oxygen is oxygen side going to oxygen here, and we balance in the form of this defect species CaTH whole. So if we want to balance this defect reaction from charge neutrality point of view, we have to put 4 holes here. So the equation is balanced. So what would be the defect species here? So 2CaO, overall defect reaction 2CaO plus O2 THO2 calcium TH plus three oxygen interstitial position plus 4 hole. So these are the overall defect reaction. So here the overall defect reaction are balanced by hole. As this the overall balance, the reaction is balanced by hole, this is called reduction defect reaction. This is called reduction defect reaction. So this is called reduction defect reaction. So in the last lecture we learned oxidation defect reaction, and right now we learned how to write or how to balance the reduction defect reaction. So one point we have to notice here, the defect species, here the defect species is calcium going to TH site and vacancy of oxygen, and calcium going to interstitial site. Electron and hole are also defect species, but for the time being we are not considering electron and hole. So you can show that the concentration of this defect species, CaO, vacancy of oxygen, and these are depending on the oxygen. So partial pressure of oxygen. So we will learn in the next class the dependence of concentration of the defect species on the partial pressure of oxygen. So by which we can write the Brouwer's diagram of this oxide, extrinsic Brouwer's diagram and as well as the intrinsic Brouwer's diagram. I would like to give a homework. So homework is just practice it if possible, and if you are not able to do it, So you can mail me or you can put in comment also. So the assignment is here we doped CaO in TiO2. So you may try with, we are doping TiO2 in CaO. So what will be the overall defect reaction? Whether it will be oxidative, oxidation defect reaction, oxidation defect reaction, or reduction defect reaction. So this is your home assignment, and if you have any doubt to understand this concept, please put your view or question in the comment, and thank you.